Here guys is I'm going to show you a couple of ways you can do this. Okay, so first way is if you go to 30, right, you go to 30 in your notes, you have a choice. You can say that cos A, cos 30. Everybody know what cos 30 is? Cos 30, it says in your on page 13 of your tables that cos 13 is root 3 over 2, and it also says that sine 30 is root 3 over 2. Is everybody happy with that? Oh, sorry, sine is a half. Now, what we've learned in the past is when you have a triangle, okay, and you're talking about an angle here, the adjacent is the one that's along the bottom, in between the angle and the right angle. The opposite is the one that it's looking at, and the hypotenuse is the longest side. Everybody agree with that?
Yes.
Now, which is easier to draw? Is root 3 easy to draw?
No.
Because it's a decimal, isn't it? So the logical choice would be to use sine. Now let me show you how to do this. To draw an angle of 30 degrees, all we have to do is this. Get your ruler out. Okay, I'm going to enlarge it just to sell the point home here. So that's large there, and I'm going to get my compass out. Now, what we have here, guys, is that the opposite is 2, and the hypotenuse we don't know. Isn't that correct? So, would you agree that if I had an angle of 30 here, the hypotenuse, because sine is opposite over hypotenuse, would you agree with that? That the hypotenuse is twice as big as the opposite. So the opposite is 1 and the hypotenuse is 2. You happy enough with that? Yeah. Now here's what I suggest you do. Draw a horizontal line. You don't know how big yet, so just draw it reasonably big. Okay. Then get your you're gonna draw up at 90 degrees, aren't you? You're gonna draw it up at 90 degrees. Now, the protractor is referring to the 30 degree angle, not drawing up at 90 degrees. So you draw a little line here. Okay. Then all of a sudden you go up 90 degrees like so, and you draw up. Okay. So draw up whatever amount. Okay, now what we said is that this one can only be how large? How big is the opposite? Anybody? Opposite is 1 centimeter. Okay, so 1 centimeter is located there, isn't it? Just there, right? Just even with that. So that's your 1 centimeter right there. How big does your hypotenuse have to be? How much? 2. So get your protractor. Rotate it all the way around there, and then make it 2 centimeters big. So where's 2? 2 centimeters big, right? Happy enough with that? Then what happens if you go up to where your 1 was marked? Your 1 was marked here, wasn't it? That's 1 centimeter, yeah, off the ground. What happens then when you come across with your protractor and you mark it down from here? What automatically is the length of that then? It's automatically 2 centimeters, isn't it? So therefore, when you link them together, what should happen is you've just after drawn a 30 degree angle. Let's see if that's the case. Everybody see it's on the 30 mark? So you just after drawn a 30 degree angle without any assistance from your protractor. Okay. I'll do it 2 more times. I'll do it for 45, and then I'll do it for 60. Okay, so when you go to 40, yes, Higgins. They say that you have to draw the angle without using a protractor. 3 different triangles. They'll only give you one of them. Okay. Next thing I'm going to go to is 45s. It says tan 45 equals 1. 1 is the same thing as 1 over 1. Would you agree with that? Cos 45, anybody? 1 over root 2. Can't draw root 2, can we? Sine 45? 1 over root 2. Which one's the easiest one to draw? 1 centimeter across and 1 centimeter up. Or the same distance across, same distance up. So let me show you what to do here. Okay. So what happens is tan is opposite over. Will everybody agree that tan is opposite over adjacent? And if I was to draw a quick diagram, A would be opposite is this side, 90 degrees, and adjacent is down here. So this is really easy. All you have to do is this. Draw one across. Yeah. And then go draw 90 degrees using memory, using your protractor again. You get the protractor out, and then you draw one up. And then what happens when you link the triangle into each other? What's that automatically have to be? Then if I measure that, where is the protractor? Automatically gotta be. There it is, there, halfway between 40 and 50. Would you agree with that? 45 degrees right there. Higgins. So, what we have next then is, I suppose what we have next is how to draw a 60-degree angle, okay? So you go, it says, want me to draw a 60-degree angle, so what I'm going to do is I'm going to go to my formulas, and I'm going to choose all the 60-degree ones, alright? So cos 60 is 1 over 2. Tan 60? Tan 60 is root 3. Is everybody reading their tables? And then finally sine 60. Now which ones can I not draw? I can't draw a root 3 because root 3 has decimals in it. So what I can draw is cos 60, which is 1 over 2. Now let me explain how you're going to go about doing this. What is cos 60 again? It's basically the adjacent followed by the hypotenuse. Adjacent of 1, hypotenuse of 2. So look what we do here. Now, it doesn't mean, we'll just do this one first and then I'll do another one of the same type, alright? So, 1 centimetre across, yeah? Okay, that's grand. Draw a perpendicular line, because we don't know how large the opposite is, do we? Do we have any idea how large the opposite is? Not really, so just draw a red line like that. Okay, then what do we do next with our protractor? Anybody tell me? Guess the next step? Anybody tell? Make it 2 centimeters. There, yeah. Then come back around. Mark it off. Okay. There you go. And then after that, link it up. And what happens when you link it up? We should have 60 degrees, right? Yeah. Let's check it out. 60 degrees on the money. Okay. Now let me explain maybe a better way of doing it. So, do you know why those diagrams are quite small? Because you're only talking about a centimetre, aren't you? Do you know what that means? It means the ratio. It doesn't mean that one of them is 1 and the other one's 2. What it means is one of them is double the other one. So I could do the same question, except this, see the way it's 1 is to 2. I could put the hypotenuse as 6, and then what would the adjacent have to be? Adjacent's the smaller one? 3. I could do 3 across and 6, and you'll get the same answer. So look at this, 3 across, yeah? Bit bigger this time. Actually, before I do this, I should actually make sure that my compass actually goes across 6 instead of wasting my time like last time. Just make sure it goes across 6 before I do anything else. I don't think it will. Okay, so I'll just make it slightly smaller. Does it go across 6 now? Just about. Okay, so 3 across, isn't it? So 3 across would take me to there, and I need a hypotenuse of 6. Will this still result in a 60-degree angle, anybody? Yeah. Why does it still result in a 60-degree angle? Sorry? Same ratio. Okay. So, what we do here is we draw up our 90 degrees here. We don't know the length of the opposite, do we? No? Okay. So therefore, what's going to happen next is we're going to get our, how many centimeters did we say this was again? 6. I think I already have it measured, don't I? Okay, so 6, yeah. There you go there. So you bring it down and then you mark it off like so. And then you link it, you draw a line, you get your ruler, you draw a line from here to here. And what's that going to be? 60. So the last one I drew was just a smaller version of the same one, wasn't it? The last one I drew was here, because it's only 1 centimeter wide and 2 up. Yes, Owen. So on these tables, guys, you're asked to draw 30 degrees. You're then asked to draw 45 degrees. Then you're asked to draw 60 degrees. So if I want to find out what cos 30 is, cos 30 is root 3 over 2. I can't draw a root 3 sine, so that doesn't work for me. Sine 60? Oh, sorry, sine 30? What's sine 30, guys?
1 over 2.
A half. I can use a half, can't I? It just means I draw an opposite of length 1 and a hypotenuse of length 2. Or an opposite that is half the size of a hypotenuse. Any size you want. It can be 10 and 5, 8 and 4, 6 and 3, 4 and 2. Opposite is half the size of your hypotenuse. What you ask me, Rory? Okay, lads, for those of you who don't know off your rhyme, so to speak, okay? Shh. Sorry, excuse me, guys. Look at it this way, okay? Cos is adjacent over hypotenuse. Sine is opposite over adjacent. And tan is opposite over adjacent, okay? Now, the truth is, if you use cos 30, what you're going to have to draw is, you're going to have to draw an adjacent of 2. Oh, sorry, you're going to have to draw an adjacent of root 3 and a hypotenuse of 2. That you can't draw that, so that one's out. Just let me go for a minute. Sine 30, if you look at sine 30, it's a half. In this case, you'd have to draw an opposite of 1 and a hypotenuse of 2, which is very easy to do. Do you understand? 2 is to 1. 1 would be twice the length of the other one. That's very easy. If I want to do 45, if I do cos 45 would be, you looking for cos 45 here, guys? 45's there, cos is there, which means this part here, 1 over root 2. I'd have to do a root 2 as the hypotenuse and a 1 along the bottom. I can't measure out root 2. Do you understand that? Yeah. Then it was to do sine 45. I'd have to do 1 on the bottom. I say 1 out here and root 2 up here. That's not, I might have to do that either. If I do tan 45, it's 1 across and 1 up, and that makes it easy to draw. So that's why I'm selecting this one for 30, this one for 45, and then finally the last one is going to be cos 60. And for cos 60, you have to draw an adjacent of 1 and a hypotenuse of 2 to get your angle. Mark.